These are questions to find the size of angles using the alternate angles of parallel lines, the equilateral angles, and the exterior angles of triangles. These questions are easier to solve than they look. 1 is too standard and too famous question. I think everyone knows that there are various ways to solve other than the one we introduce. Add parallel lines to two parallel lines. Since the alternate angles of parallel lines are equal, we can move angle x. (35° can also be moved in the same way. If you add angle x and 35°, you will find that it will be 80°, so you can find angle x by subtraction. In this way, the basic idea is to collect the angles that are scattered in the question in the same place and solve it. However, we will bring 60°, which is far away, closer to angle x. Alternate angles of parallel lines are equal. There are many other ways to solve it, but this time we will calculate 20° next to 160°. Subtract from 180°. Corners gathered around one triangle. The exterior angle of a triangle is equal to the sum of its non-contiguous interior angles. 20° and angle x add up to 60°. So, if you calculate 60° to 20°, you can find the size of angle x. In 3, the number of straight lines increased and it became difficult to understand which part to focus on. Angle x should be easy to calculate if you know the angle next to it. You can move 80° by using the same angle of parallel lines. Let's try to pay attention to the places necessary for calculation first, thinking, if we know where, we will know the answer. Now let's gather the angles around angle y. Let's move 50° using the same angle of parallel lines. Since the vertical angles are equal, we now have the angles gathered around a single triangle. The exterior angle of a triangle is equal to the sum of its non-contiguous interior angles. By adding 50° and 80°, we can find the size of the exterior angle y. 4 can be solved with this figure as it is, but it will be easier to solve if you add a straight line yourself. I will introduce 3 solutions. First, it is a method that can be applied to other questions. Extend one side of an equilateral triangle. Then, bring other angles closer to angle x. The alternate angle of parallel lines is 47°. And since it was called an equilateral triangle in the question, we will use the fact that one interior angle of an equilateral triangle is 60°. The exterior angle of a triangle is 60°, and the interior angles that are not adjacent to it are 47° and angle x. If you add 47 degrees and angle x, you get 60 degrees. Subtracting 47 degrees from 60 degrees gives angle x. There is also a method that does not add lines. In the alternate angle of parallel lines, this angle is 107 degrees, which is the sum of 60 degrees and 47 degrees. And since there is 60 degrees next to it, the remaining angle is 13 degrees by subtracting 60 degrees and 107 degrees from 180 degrees. I will also show you how to solve using parallel lines. There will be a lot of calculations, but I think there are many junior high school students who can come up with this solution. After drawing a parallel line, use the alternate angle of the parallel line to bring 47 degrees closer to angle x. Subtract from the 60 degrees interior angle of the triangle to get 13 degrees. This is the alternate angle of parallel lines, which is equal to angle x, so we know that angle x is 13 degrees. Five is just an equilateral triangle turned into a regular pentagon. Since the method of obtaining is the same, only the method of extending one side will be explained. Find one interior angle of a regular pentagon. First find the sum of the interior angles. Subtract 2 from 5 and multiply it by 180 degrees. The sum of the interior angles of a regular pentagon is 540 degrees. There are 5 interior angles, so if you divide by 5 to find one, you get 108 degrees. Subtracting 108 degrees and 23 degrees from 180 degrees leaves 49 degrees. This is the alternate angle of the parallel lines, which is the angle of the triangle containing angle x. Finally, since the exterior angle is 108 degrees, subtract 49 degrees from this to find the size of angle x. Six is obtained from angle y. Think about how you will find this angle y in the end. Angle y is an exterior angle of this triangle, so I realized that if I know this angle, I can find it. And this is readily apparent in the vertical angle. The exterior angle of a triangle is equal to the sum of its non-adjacent interior angles, so add 40 degrees and 58 degrees. Angle x is included in this triangle. And the exterior angle of this triangle is the same as angle y, which is the same angle of parallel lines, so it is 98 degrees. Subtracting 35 degrees from 98 degrees leaves angle x.